Aha. So here's a case where we're going to use the sum. So here, whenever you see like a floor function like this, then we will do a sum from this would be n goes to 0, and then you do n to n plus 1 like that, because a floor function is between n to n plus 1. So because this is n plus 1, we have to take this bound, subtract it by 1, so that gives us 2019. So be very careful about that. Don't forget to subtract 1 right here. So this becomes 2019 because of the n plus 1. All right? Don't forget about that. Now, we can let x minus, and then you let n, the floor function, n, then cube, and then dx. Okay, so that's how you deal with integrals like this. So this is the summation way. Uh, Before we had to do it manually because it was the balance was the bound was no bueno. So here, because it's mainly integers, uh, it's much easier for us to deal with. Now we can just do the summation. This is so this n you just treat it as a constant. So let u equal x minus n, because honestly I am not gonna express that. So you leave the sum. I'm just gonna draw an arrow. You leave the sum. If you plug in the bounds, x, that's 0, n plus 1, that's 1. Get u cubed du, right? What this gives us is this gives us sum of from n to 0 to 2019. This integral here is just, I mean, we know that this by power rule, plug in 0, 1, this becomes 1/4. So we have 1/4, and then plug in 0, that's 1/4, all the way to 2019. So technically we have 2020 divided by 4, because we're using 2020 terms times 1/4. So the answer is 505. That is our answer for this integral.